Hey guys, so we're going to do a quick video on solubility rules and net ionic equations. So I want to just give you a little bit of information so it makes it easier for us to be able to talk about it during class and do some practice with it. All right, so let's go ahead and get into this slide. As we're discussing solubility rules and net ionic equations, the very first thing we need to know is solubility rules. So let me move my camera up here, and I can talk to you about these rules. The first rule says all group 1 metals and nitrates are always soluble. So let me talk about what that means. First of all, when I say the word soluble, what that means is an ionic compound can be put in water, and when it's put in water, it actually dissociates into its separate ions. Here's a picture to show you what it looks like. So what I have here is NaCl. When I stick NaCl into water, then this is supposed to be a little beaker of water here, then you will see that it goes into its Na plus and the Cl minus ions. It actually separates into those separate ions. This means that this compound here, this ionic compound, is classified as soluble. Whenever you see this written in a chemical equation, you'll have a little AQ. Let me see if I can work backwards here. You'll have a little AQ written beside it. Like you have like little S's for solids, little G's for gases, and little L's for liquids. This will be represented as AQ, and what that means is that it's soluble in water. It will split apart into its separate ions when it's in water. Okay, if I have something that's not soluble, for AgCl, for an example, then how I will see this is as a solid. So this little compound here will stick together. It will not separate into its separate ions like this does. Instead, it stays together as one compound. And what I can visibly see here is that I have a little solid floating around at the bottom here, and it's separate from that water solution mixture. So now that you know kind of what solubility means, let's go through these different rules. So group 1 metals and nitrates, they are always soluble. So that means that they will always behave like this. Split apart into its ions. We call it solubility. We call it soluble. We say that it's aqueous in a reaction. Now, group 1 metals, let's figure out where those are at. If I get the periodic table here, group 1 metals are located in this very first column. So this periodic table looks to you guys like it's like a mirror image, just because I'm presenting from the webcam. But if you look on your own periodic table at this very first column, all right, group 1s means very first column. Groups go down on the periodic table and periods go across. So when I say group 1, it means this first group here. Whenever I see these in a compound, in an ionic compound, excluding hydrogen, then they will always be soluble. So remember that it splits apart into its ions. One other thing that's always soluble is nitrates. So nitrate, let me see if I can draw that on here. This might not be too pretty, but we'll go with it. NO3 minus, that is the polyatomic ion nitrate. That is one that you do have to memorize. Anytime you see nitrate in a compound, that's also always soluble. So it just happens to where it splits apart into its separate ions. Strong acids are always soluble. You should have a list of all of your strong acids. Strong bases are also always soluble. These strong acids here, there are 6 that you need to memorize, and they are listed on your periodic table. If not, then I will make sure that I give them to you in class. Strong bases, I can actually show you on the periodic table. So where I find my strong bases, again, is in this group 1 column, lithium all the way down, as well as the second column, starting at calcium here. So if you look on your own periodic table, starting at calcium, you see strontium, barium, and radium. So you'll go down lithium, and down on the second group, starting with calcium. If any of these things are combined with OH, so it has a hydroxide compound, then it is classified as soluble as well. The next thing, or the next rule that we need to go over is group 17 halides. So group 17 on our periodic table, that is over here where fluorine and chlorine and bromine and iodine, you see group 17 going all the way down here. Anytime those guys are in an ionic compound, they are soluble. However, there are 3 that it's insoluble with. Now remember, insoluble means that it does not break apart into its separate ions. It stays together as that solid. And what we call that solid in the solution is the precipitate. And we'll talk about that in class. So the 3 that these guys are not soluble with, it will form a precipitate, it will form that solid, is silver, mercury, and lead. All right, so silver, mercury, and lead, these guys are in this area. You have silver here, number 47, that's in your transition metals. Mercury, which is number 80, in your transition metals as well. And lead is 2 over at 82 in that little P block there. So silver, mercury, and lead, anytime those are paired with chlorine, bromine, iodine, fluorine, then it is classified as insoluble. So let's go back to this picture here that I drew. Notice when I gave you an example of an insoluble compound, I gave you silver chloride. So this is an example of one of those exceptions in which this is an insoluble compound. It will form a little solid in the solution, which is the AgCl, silver chloride, and that is known as the precipitate. If we write this in the reaction for our net ionic equations, we write a little S in parentheses instead of the AQ. The last one is sulfates. Now, sulfate is another ionic compound. That's SO4. Let me see if I can draw that here. SO4 with a 2- charge. So anytime you see sulfate in an ionic compound, it is soluble unless the 3 guys we just talked about, silver, mercury, and lead, and there's 3 others. Calcium, strontium, and barium. So on the periodic table, calcium, strontium, and barium are very close together. They're in the same group, the group 2, calcium, strontium, and barium. They're all 3 in this group 2 right here. So if sulfate is with either of those 6, it will not be soluble, so it'll stay together, it will form a precipitate. It will not break apart into its ions. So that's it for our solubility rules. Now let's see if we can put this to practice. All right, so here we are again. We are working on solubility practice, and so we want to take these solubility rules that you see to the right over here, and we want to classify each of these compounds of whether they will be soluble or not. Now remember, if it's soluble, it breaks up into its ions according to these rules, and that means if I write it in a reaction, I'll have a little AQ beside it. If it is insoluble, that means that it does not break into its ions, and I'll write a little S beside it in a reaction because that means that it will form the precipitate. So let's go ahead and get started. Our very first one that we have is iron 2 nitrate. So that's number 1. So I need to first classify if this is soluble or not. So I look and see if any of these things apply to the rules that we have here. I see that I have a nitrate that's present here. So I remember that all nitrates are soluble. So nitrates are always soluble there. So this compound, iron 2 nitrate, would be classified as soluble. And if I write it in a reaction, I would write a little AQ. Let me show you what I mean by that. So I would write a little AQ beside it in a reaction. For the second thing, it's sodium acetate. This is the acetate ion here. I look and see if I have any rules according to this. So I don't see a rule for acetate, but I do see a rule for group 1 metals. So Na is one of those group 1 metals we talked about, and it is always soluble.